Hi guys, I hope you are fine. Me too, I'm fine. Thank God for this opportunity that He has given to us so that we can learn together. So guys, we're now going to go to integration. And so guys, welcome as I start the lesson. So guys, we are looking at this question and we can read it. Find the volume of the solid generated by revolving the region between the parabola, that is the parabola, and the line x equals to 3. About the line x equals to 3. I've already drawn the graph, guys. This is the line x equals to 3. So the first thing, guys, we want to find or to do is to draw the diagram or the diagram of the parabola. So first of all, we find out where it touches the x-axis. And where it touches the x-axis, guys, for example, when that parabola touches the x-axis, guys, for example, maybe at a certain point here or anywhere, it means then that our y-axis, this y-axis, the y is equals to, will be equal to 0. So we find out now when y is equals to 0, what is our x? So we shall come and use the equation that we will say x is equals to y is equals to 0 plus 1, and so x is equals to 1. So that parabola touches x at 1 at this point. And then we now want to find when it touches this line. And when it touches this line, for example, first of all, we can write 1 there, because we have found when y is equals to 0, x is equals to 1. Now we want to find when it touches this line. When it touches this line, then x is supposed to be 3. So we shall put our x here as 3 and now find out what is y now. So this is going to be x is equals to 3. This now will give us y squared plus 1. And then when we can bring it this side, we shall have now 3 minus 1, which is 2, equals to y squared. Therefore, y is going to be equal to, if we now find the square root of this side and the square root of this side, we shall get y is equals to square root of 2. And this one, guys, can also be equal to, y can also be equal to negative square root of 2. Because if you multiply them to find the x, so to find the y, if you are going to square this side and square this side, you'll get that both of them are the same. And so, guys, you'll have to put here square root of 2, and then still another one, negative square root of 2, is still brought about by putting 3. So we now come and look at our equation here, our graph here. We shall have this side, we have negative square root of 2, and this side we have, around that place, negative, this is positive now, square root of 2. So we can draw, because it's a parabola, it will look like a curve like this, guys. So this one will look something like that. And then it will come up to that point. So guys, this is our parabola. And now, guys, the question we have is supposed to be rotated about this line. So when it is rotated about that line, it is now going to be a solid like that, a solid which is now going to be cylindrical, only that it is now, it's irregular. And guys, so guys, it is going to look something like this. This is how what we are going to expect to have, guys. As you can see, this one is a model of that cylinder, but now it has been cut into two, and also it has been cut here. Here it has been cut, and here it has also been cut so that it is not complete. So the outline of that model, this line is the one that is forming the parabola, and it is this. Then from here, guys, you can see here, which is the center. This one is cut into half so that the other half is underneath. It's assumed to be underneath. So from this point, guys, up to this point, that is, maybe I can draw it here, guys. From this point here, up to any point here, like that, we are going to have our radius at that point. So that, guys, we can actually draw something that looks like this here, something like that, which is now having a radius. Let's call that radius R, like that. And this radius R is for that simple element, that element at this point. At this point, an element, we can remove it, will have a radius R. At this point of that element, we have our 3. You can see the 3 there. S equals to 3. And at this point, we have our parabola, which is, this point is x equals to y squared plus 1. And so, guys, we can get the area of that disk. Not the area, but the radius. And the radius is going to be 3. We are going to have 3 minus y squared plus 1. That now is going to form our radius. So this one is eventually going to be 2 minus y squared, like that. So this one becomes our radius for that element. So, guys, when we now come to find the volume of that, this small element, we know that the volume of a disk like this, volume, let's call it dV, like this, d, because it's a small element like this, is supposed to be given by pi r squared h, where r, we have it here, and the h, guys, is along the y-axis. Because it is along the y-axis, we shall call it dy. So we shall say this is equals to, let me write it here, pi r squared is going to be 2 minus y squared, like that, squared, and then our h, because it's along the y-axis here, it's along the y-axis. Of course, this line is x equals to 3, but along that axis is the same as this, which is y. So this one is going now, for this here, is going to be dy. So we write here dy, like that. Like that. So this is our dv. So with that in mind, guys, we can now come and find out what is the volume of our cylinder. So let me transfer that equation here down here, so that now we can do that. The equation here is that dV is equals to pi 2 minus y squared dy, like that. So I've transferred that, and that one is for a single disk. Remember, there are such kind of disks from this point up to this point, and they begin at, now what we say guys is that this disk, it's like we are summing up those small disks. We are summing them up from negative square root of 2 to square root of 2. When we sum them up, all those disks, let's call it, we can call it this. These are the number of disks is from here to here. We put here pi 2 minus y squared dy. If we sum them up, then we are going to get our final volume. But now guys, we do not use this. We use now what we call integration, and which I'm going to write it here down. So it is written like this, guys. It's written like, now V is equals to integration with from negative root 2 positive root 2. We write pi, we can write here because it's a constant. Then here we write 2. Can now remove this one, guys. Can do away with that. And now I write here 2 minus y squared dy. So now, and this one is squared, guys. We forgot that this is supposed to be squared because it's pi r squared. So now this is what now guys we are going to do. So now guys, we shall have V will now be equal to pi. We now do integration from that to that. If we square this one, we shall have 4 minus 4y squared plus y raised to 4, like that. Then we put our dy there, and then we continue. From there we shall have, we integrate that. Now this one will be pi. Now from that to that, we now come and integrate this one. So this one will be, but guys, we have to write it again because when we integrate we don't put this. So this is going to be 4y squared plus y raised to 4, like that, dy. So let me now integrate, guys. This is going to be V equals to pi. I now integrate. For this one is going to be 4y, like that. And this other one is going to be 2 plus 1 is now 4 all over 3y cubed plus y raised to 4 plus 1 is 5 all over 5, like that. And this one now guys is now from root 2 negative root 2 to root 2, like that. So guys, we shall now have V will be equal to, now we put that, we put pi there, then we put a bracket like that. So the first one will be 4 pi 2, we put this one first, minus 4 over 3, like that guys, 3 plus root 2 raised to 5, like that, all over 5. This one now we minus 4 negative root 2, like that, minus this one we put that like that, 4 over 3 root 2, that is negative, raised to 3, and then finally we can put here plus negative root 2 raised to 5 all over 5, like that, so that we have our bracket there. So our volume is going to be equal to pi. For these guys, this one is going to be 5.65 by use of calculator. We come to this negative, for this is going to be 3.75, that is 3.73 using the calculator, and then finally this one is going to be plus 1.114, like that, and then minus, this is going to be minus, we can maybe come here, down here, like that, so that we can put this one like this guys. So this one is going to give us minus 5.65, like that, plus this one is going to be 3.73, and here we have minus 1.114, like that guys, so that finally our volume we will have 3. If we add up this one, there will be 3.034 minus 3.03, like that, so that guys our solution is going to be, now is going to be 6.068 pi, because here we had pi here, unit squared, cubed, like that guys. So that is our solution guys. And so guys, that's how we do such a problem. It's supposed to be done like that up to when, then we start with that, we do it like that guys, up to when we get our solution there. So that was our question there. And so guys, have a good day, or a good night, or a good evening.